We're going to do some trig graphing, and since I don't have the study guide to actually know which problems I gave you, I'm just going to pick random ones from the book. So the first one I have is y is equal to -6 sine pi over 3x plus 4. Since this is a sine wave, we could use that technique I showed you. So remember, step 1, let's find the amplitude and period. The amplitude is 6 because it's the absolute value of -6, and then the period is 2 pi over 3. When that happens, the pi's cancel, and it's going to become 2 times 3, so your period is 6. Step 2 is I'm going to take 6, I'm going to divide it by 4 to get the interval length, and 6 divided by 4 is 3 over 2, so your interval length is 3 halves. Now, for this is a sine function, so I'm going to find my 5 points. Since it's sine, I know that it starts at 0, goes to 1, 0, -1, 0. So my first point is going to be 0, 0. My second point is 3 halves because my interval length is 3 halves, so I'm going to add 3 halves to each point, right? I'm using my interval length for step 2. So 0 plus 3 halves is 3 halves, and I know my y value is going to be 1 since I know sine goes 0, 1, 0, -1, 0. My third point is going to be 3 halves plus 3 halves is 6 halves. 6 halves can reduce to 3. And I know I'm going to be at 0 since I'm using the y values up here. And then I'm going to add 3 plus 3 halves. Remember, 3 is really 6 over 2, so 6 over 2 plus 3 over 2 is 9 over 2, and my y value is -1. And then my last thing that I'm going to do is 9 halves plus 3 halves is 12 halves, which is 6, and my y value is 0. Now, step 4, there are 2 things happening here. I am multiplying by -6, and then there's a vertical shift of 4. Okay? So I'm going to do 2 things to my y's. I am going to multiply my y's by -6 and then add 4. So my first point is going to be at 0, and then I'm going to 0 times -6 is still 0. 0 plus 4 is 4. My next point is going to be 3 halves, and 1 times -6 is -6. -6 plus 4 is -2. Then this becomes 3, 4. 9 halves, -1 times -6 is +6, and 6 plus 4 is 10. And then the last one, 6 times 0, no, sorry. It's going to be 6, and then 0 times -6 is 0. 0 plus 4 is 4. So those are my points that I'm going to graph. Let's go ahead and graph it right here. I know that my interval is going to be, let's actually make it. So I know my interval length is 3 halves, so I'll be at 3 halves, I'll be at 3, I'll be at 9 halves, and I'll be at 6. At 0, I'll be at 4. At 3 halves, I'll be at -2, so I'll be down here. At 3, I'll be at 4. At 9 halves, I'll be at 10. And then at 6, I'll be back at 4. So I know my sine wave is going to go through here like this. Okay. And then I know that it's an odd function, so I know at -3 halves I'll be at 10. Okay. Then at -3 I'll be back at 4. At -9 halves I'll be down here at -2. And then at -6 I'll be back at 4. So I'm going to continue my graph. So that is your sine wave for this problem. Okay. That one shouldn't be too bad. Pretty straightforward. Now, remember when there is a phase shift, though, you do have to change how you have to do something with the period first. So what I'm going to do is I'm going to pick a random problem that I assigned. Let's do a cosine wave this time. Let's do y is equal to -2 cosine 2x minus pi over 2. Okay. Now remember, when we have these problems, what we need to do is we need to make sure the coefficient for the x is 1. There's a 2 out here, so I'm going to factor out the 2. So this becomes y is equal to -2 cosine 2, and then in parentheses, x. Now, if I factor out a 2 from pi over 2, I'm really dividing pi over 2 by 2. So this becomes pi over 4. Okay. So now let's find the amplitude. Amplitude is the absolute value of -2, so that's 2. And the period now, I can use this 2 that's right here, that I pulled out. My period is 2 pi over 2. So my period is equal to, my period is 2 pi over 2, yes, so my period is equal to pi. So step 2 is I'm going to take pi and I'm going to divide it by 4, so I get that my interval length is pi over 4. Step 3, I'm going to go ahead and pick my points. Now remember, if I have a phase shift, my phase shift is where I start. So since the phase shift is minus pi over 4, I know that minus pi over 4 means I move to the right by pi over 4 spaces. So my first point will be at pi over 4. Now remember, cosine starts at 1, then it goes to 0, then it goes to -1, 0, and then back at 1. So those are my y values for my point. So pi over 4, my y value will be 1. My interval length is pi over 4, so my next one is pi over 4 plus pi over 4 is 2 pi over 4, and that reduces to pi over 2. Pi over 2 will have a y value of 0. Then pi over 2 is really 2 pi over 4. 2 pi over 4 plus pi over 4 is 3 pi over 4, and that's going to have a y value of -1. 3 pi over 4 plus pi over 4 is 4 pi over 4. So that is pi, and it's a y value of 0. And then I'm going to have pi plus pi over 4. That's going to be 5 pi over 4. And my y value is 1. Okay? So the only thing that changed from this problem to last is that we have a phase shift, and that's where I start. Now, the only thing that happens here is that I'm going to have a vertical stretch of -2. Remember, we already applied the horizontal shift by starting at pi over 4. So the only thing that you have to do for step 4 is multiply all your y values by -2. So this is pi over 4, -2, pi over 2, 0, 3 pi over 4, positive 2, pi 0, and 5 pi over 4, -2. Okay. It's getting hard to see. My marker is running out. Okay. So these are the points that I graph. I'm going to go ahead and graph pi over 4, and I know it's at -2. I know pi over 2 is 0. 3 pi over 4 is at +2. And then I know that pi is at 0. And 5 pi over 4, I'm back at -2. So my cosine wave looks like that. And since it's even, I know at pi over 2, I'll be back here. At negative pi over 4, I'll be back up here. So I know it's going to go up here and down here. Okay. So that is my cosine wave. Hopefully these aren't too bad. I think most of you understand how to do these ones. Now let's go ahead and do something that's like a tangent with the shifting. So I'm going to erase this. So the next thing that I'm going to do is I'm going to graph y is equal to, and once again, this is a random problem. It might not be in your study guide. Tangent of 1/4 x plus 1. Okay. Now, best thing to do is to kind of memorize, or not really memorize, but know how to graph the tangent function. If you have a unit circle, I know okay, make sure you know that unit circle. Oh. It is 1, 0, 0, 1, negative 1, 0, 0, negative 1. I need to get a new marker, by the way. Tangent is sine over cosine. So I know it's going to be undefined at pi over 2 and 3 pi over 2. Because that's where the cosine is 0, and you can't divide by a 0. So I'm going to have, when I draw my graph, my regular tangent, I already know at pi over 2, so if we're going to have intervals of pi over 2, I know that at 3 pi over 2, at all of these okay, I know all of these are going to have asymptotes at the pi over 2, odd integer pi over 2. And remember that tangent goes through these zeros, and it's going to be, this is the regular tangent graph. Right? Okay. So you should all know how to create the regular tangent graph. It's really not that difficult. You just have to remember that it snakes up this way. And remember, cotangent starts from up here and goes down. Okay. If you forget which direction, think about the unit circle, and remember, as we get really, really close to pi over 2, my x values become really, really small. So if I divide by a really, really small number, it's going to become really, really large, my y values. Okay. Now, there are different transformations happening here. Okay. What's happening here is that I'm having a horizontal stretch of 4, and I'm going up 1 based on that second one. Okay? So, remember, what I said is that you don't really have to do it on this graph, right? Because this graph, it's going to be hard to it's going to be really hard to do these transformations on this graph. So what I urge you to do is to create an entire new graph. Since I'm doing a horizontal stretch, okay, all of these vertical asymptotes are going to be stretched out as well, right? Because these are vertical asymptotes, so if I stretch it horizontally, these are going to move out and the vertical asymptotes need to move. So what I'm going to do is I'm just going to focus on this middle interval. And for the test, you could just focus on the middle interval to do all of your transformations. Okay? So I know that if I'm going to stretch negative pi over 2, if I'm going to multiply that by 4, my new asymptote will be at 4 times negative pi over 2, which is negative 2 pi. So I know that I am going to make a vertical asymptote at negative 2 pi. Now, at pi over 2, that is going to be stretched out also by 4. So 4 times pi over 2 is really 2 pi. Okay? Now, you also should remember where tangent is equal to 1. So remember that it's equal to 1 at pi over 4. And then this point right here is negative pi over 4, negative 1. Okay? So if I am going to take this point right here and do a horizontal stretch by 4, 4 times pi over 4 is really pi. And since I'm going to move up 1, the y value becomes 2. So my new point is going to be at pi 2. And then this point right here will also get stretched by 4. So I'm at negative pi, and I'm gonna move instead of negative 1, I'm gonna be at 0. Okay. So you see that the curve is gonna snake up this way, and then at 0, 0, the point 0, 0, horizontal, it stays at 0, but I'm gonna move it up 1. Now it becomes 0, 1. So I know it is going to snake that way. Okay? And if you're able to show me this, you'll get full credit on the problem. Just this one little section and apply all of your changes to that. Okay? Now we have one last graph to do. Let's go ahead and pick a cosecant one. Okay. So let's say I have y is equal to 3 secant 1/4 x plus 1. Okay. Now, I'm going to show you a technique here that might be much easier for you if you don't like transformations. Now, it's perfectly fine that you could do the cosine wave and do the 3 transformations. However, I didn't tell you this in class, but you could actually change this to the cosine function with a period of 1/4, a vertical stretch of 3, and add 1. I'm going to do the technique that I do graphing the cosine function. Okay? So what I'm really going to do is I am going to find my amplitude and period of this. Just like I'm going to pretend this is cosine. Okay? So I'm going to pretend I'm graphing 3 cosine 1/4 x plus 1. My amplitude is 3. My period is 2 pi over 1/4. And so my period is 8 pi. My intervals, so step 2, my intervals is going to be 8 pi divided by 4. I'm going to have intervals of 2 pi. It's cosine, so I know cosine goes 1, 0, negative 1, 0, 1. Okay. And then what's going to happen here is my points now are going to be, starts at 0, 1. Then I'm going to have intervals of 2 pi, so it's 2 pi, 0, 4 pi, negative 1, 6 pi, 0, and 8 pi, 1. Okay? And then I'm going to go ahead and multiply the y value by 3 and add 1. So my new points are going to be 0, 4. They're going to become 2 pi, 1. It is going to become 4 pi, negative 2. Hope that's right. Yeah. 6 pi, 1. And then the last point is 8 pi 4. Okay? Now, see how these are my points? Just go ahead, and what you can do is you can graph. So I'm going to erase everything else and just leave step 4 there. Okay. And what I'm going to do is I'm going to graph these points. So at 0, I'm at 4. At 2 pi, I'm at 1. At 4 pi, I'm at negative 2. At 6 pi, I'm at 1. And at 8 pi, I'm back at 4. Okay, I'm going to go ahead and connect that, my cosine wave. I know that it's going to be an even function, so I know at negative 2 pi, I'm here. At negative 4 pi, I'm down here. At negative 6 pi, I'm at 1 again. And then at negative 8 pi, I'm back up at 4. So this is my cosine wave. Okay. So, see, now from here, what I could do is I can find okay. Now the trick here is, that's my cosine wave. The trick here is to find my asymptotes. Now remember, secant is 1 over the cosine. Okay? Now, if I have the cosine does not exist at pi over 2 and at 3 pi over 2, 5 pi over 2, 7 pi over 2. Secant will be undefined because cosine will be 0. Now, however, those are vertical asymptotes. But the vertical asymptotes are going to have, I'm going to stretch out by 4, right? 1/4 x is, it's a horizontal stretch by 4. So if I have a vertical asymptote at pi over 2 for my regular cosine function, for my regular secant function, I know that if it's a horizontal stretch of 4, this is going to be 2 pi. Okay? So I know that at 2 pi and at negative 2 pi, I am going to have asymptotes. Okay? And see, if I had 3 pi over 2 as an asymptote, if I multiply that by 4, I'm going to have an asymptote at 6 pi. So I know at 6 pi and at negative 6 pi, I have an asymptote. And so remember, the secant function is just a reciprocal, so I know my secant function will just look like that. Okay? And you could go ahead and erase the cosine wave. And so your secant function is that with the vertical asymptotes there. Okay?